Okay, so for tutorial sheet 5, the question was find the vertical asymptote, if any, and the values of x corresponding to the odds, any of the graph of each rational function. So for this question, your goal is just to find the vertical asymptote and the odds. So you know that we've been given this function here, this rational function here. So now, how do we find the vertical asymptote? You know that the vertical asymptote, those are values that make this function to be undefined. So you know that when we get this instead and equate it to 0, you know that there is a 0 down here. Sorry about that. So when we equate this guy to 0, we find those values that will make this function to be undefined. So we discover that x is equal to 0 or 4 is equal to -4 here. So our vertical asymptote is just when at x is equal to 0 or x is equal to -4. So now when you look at this function here, it has no holes because there's nothing common in both the numerator and the denominator. So this function has no holes. So that's how you conclude that there are no holes in this graph or in this rational function. Are we clear for the first part?
No, sir, it's not clear.
Huh?
Kindly repeat.
Okay.
It's not clear.
All right. I was saying that when you have been asked to find the vertical asymptote, right? You have to find out what can you do to this function. Such that what values of x can you put to this function that will make the function to be undefined. So when you look at this data here, when, the function will be undefined. Okay. So when we have a 0 down here, this function will be undefined. Yeah, this function will be undefined. You get this denominator to 0 to solve for those values that will give us a 0 here in the denominator. So now, when you discover that x is equal to 0, now if you put a 0 here, isn't it? It will be 0 times everything. So you have x plus 3 over 0. Now, anything, this this rational function on top, right? And then the denominator, when it's 0, it simply tells you that this function is undefined. So that would be your vertical asymptote. Is it clear though? Yes, is it clear now, people? We proceed.
Sir.
Yes. Yes, go on, please.
Sir, so now what happens to the x plus 3?
X plus
The numerator.
we don't consider the numerator when normally we just focus on the denominator. What would the function like? If you check, looking for like what values? Like, you remember when we are doing the domain, when we are doing domain, moving those values.
Yes.
Then isn't it?
Yes.
So what's the domain for this guy? The domain. What's the domain for G of X?
Negative.
Huh? What's the domain? Huh? What's the domain?
Okay.
We have forgotten. Okay. So the domain for this function is except. Remember that say except 0 and 34. Those except ones, those are what you have passing to, which means our function, no matter what it says, it must not ever pass through these lines, the 0 and 34. Is it clear though? Because if we cross 0, this is 0 and -4. It simply means that the function
Yes.
is now clear.
Yes, sir.
So, if you notice that here there are no functions, like I said, I'll show you an example of where we was a function.
Sir, I don't know what's wrong with your mic.
Is it now clear?
It's clear, but people have to mute their mics because there's an echo.
All right. Mute everyone. Okay, so we now go to this part. You know that we're still dealing with question 1. We're still looking for the vertical asymptote and the whole, isn't it? So now I've been given this function. So now if you notice that our function here, our rational function h of x is equal to x over x open x minus 3. This guy, we can easily say that we can simplify this, isn't it? You know that x and x can cancel there, and we have 1 over x minus 3, isn't it? Now here, since this is our new function or rational function, isn't it? What will be the vertical asymptote for this function here? So the vertical asymptote for this function is vertical asymptote is equal to 3, because when we equate this guy to 0 and so for x, we discover that x is equal to 3, which is our vertical asymptote. So now the x which we cancel, that one, the one which we have cancelled there, it simply tells you that there is a slant, isn't it? Well, oh, sorry, there is a hole in it. So now the hole, the value of x corresponding to that hole is 0, isn't it? So now here we have noticed that there was x and the x there, isn't it? So I've cancelled that. So now there is a hole, which means that a hole is simply a line that a function passes through. Now we have to indicate a hole on it, such that it's simply telling you that at that point the function is not really defined, but it's just passing through that point, the hole. I don't know if you have gotten that part though.
Sir, kindly repeat.
I'm saying for this guy, since you have noticed that we have a common thing here, X is common both on the numerator and denominator, right? So we can cancel the X on the numerator and cancel the X on the denominator, right? So we have a new function, which is this guy here. This guy is the one we're going to solve the vertical asymptote for it. And then you know that the vertical asymptote is simply those values that to make this function to be undefined. So when you notice,
Yes.
equate this guy to 0, find that your vertical asymptote is limited. But we have that
Yes.
common factor, which is X, right? The X that we have,
Yes.
that's what we are calling a hole, which is taking place at 0, isn't it? So here we know that when X is 0, the function will be undefined, isn't it?
Yes.
But since it's common, we can easily cancel it and make that function to be when you're sketching this, there will be a hole when you sketch this guy here. It's just that we're not required to sketch this one. So you have something like when you're sketching, I believe you have something like it will be a line, isn't it? But when it passes through that hole, which will be at 0, right? It will be like this. Don't know if the graph will go like that or probably like this, isn't it? But there will be a hole here telling you that this is where the X value is, which is 0 here. 0 is somewhere, isn't it? Which is a hole. But the function will automatically pass through the hole. You have gotten it now.
Yes, sir.
So now we proceed now. I've shown you how to find the vertical asymptote and if there's a hole in the graph. So when you have X is equal to 0, so this just tells you that the hole will take place at 0, negative 1 over 3. How do we get this negative 1 over 3 this side? We take this hole of ours, which is 0, isn't it? And plug it in where with this new function here. So it will be 1 over 0 minus 3. That's why we're getting this guy here, the negative 1 over 3. Have you seen that?
No, sir.
Discover that there's a hole here, isn't it? Which is taking place when X is equal to 0. So we know that when X is equal to 0, this function will be undefined, isn't it? So now, since we have common factors, we can cancel these two, isn't it? And we will have something that we are calling a hole, a point which the function passes through. But that point is not really defined by the same function, isn't it? So now, the issue is that when you find the value that corresponds to your hole, you have to plug it in this new function, which is here. So when we put 0 on X here, we have 0 minus 3, isn't it? So which is equal to 1 over negative 3, which will be your Y value now. So now when you're creating the point of hole, you're trying to plot where the hole is. You just plot where, when X is 0, isn't it? You have 0, negative 1 over 3, which is your Y value, this is your X value. Is it now clear?
Yes.
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 Yes, sir.
Sir,
Yes,
Mr. Mkuga,
yes.
on the first question, I'm a bit confused. How did you conclude it?
Others,
Yeah, I can smell.
so on the first part, well, this question here, we discover that you know how to find the vertical asymptote by now. We discover that there are no common factors in both the numerator and denominator, isn't it? So this simply tells you that this rational function here has no holes, and the conclusion was there are no holes in this graph or in this rational function. That's how you conclude, because there's nothing common. You can't cancel anything there. So this function specifically it has no holes. Is it now clear, please?
I don't know it, but I can see a common factor, X on top and X on down. I think they can cancel each other.
Here. This is X plus 3.
Exactly.
You have seen this is X plus 3, right?
Yes.
But here we have X, isn't it? So this X and that X cannot cancel unless if you factor out the X here, but which will make the function look a little bit different, because if you factor out the X here, you have 1 plus 3 over X again, isn't it? Which one truly makes sense? But if we had x plus 3, and down here we had x plus 3, isn't it? Not of 4. We could have cancelled out this common term, but here we can't see any common term here, both on the numerator and denominator. I don't know if you are able to see that one.
Yes, thank you.
All right.
Sir, but how come this x is equal to 0, and on the other one you are saying it's equal, or I mean it has a whole, and you are saying it's x is equal to 0 again.
Here for vertical asymptote, we're equating the denominator equals to 0, isn't it? We're okay with that part.
Yes.
Now for the strand, we're looking for something which is common, isn't it? Now for these guys, there's nothing common. But when you look at this one here, you notice that this is just alone, and then there's also x which is just alone, isn't it? So we can cancel, isn't it? And we have this new function here, 1 over x minus 3, isn't it? So we equate this guy to 0, isn't it? To get
Okay, in the conclusion, where is the x is equal to 0 coming from? That's why I'm not clear. In the conclusion for the second one, which is having a whole.
So you know when we put 0 on x here, what this function would be defined or undefined?
Undefined.
Yeah, so that's where the 0 is coming from. Because when you put any value here apart from 0, this function will be defined, isn't it? Apart from 0 and isn't it? So now we notice that
Yes.
if you notice that is where your O is. Since, these guys and that guy can cancel. And then here when you put a 0 next, this function will be defined, this new function, isn't it? Yeah, but on this one it won't be defined. So like it's accepted the whole. But the whole is like a point with a graph but it's not defined. So when you look at here, the value of x corresponding to the whole x is equal to 0. So when you have x is equal to 0 here, this function will be undefined. But when you cancel the common term and you have x here, when you plug in 0, this function will be defined. Is that clear though? Where the 0 is coming from?
Yes.
Okay. F. So now for f, we looked at this quadratic one. We have a quadratic function down here. How do we go about this guy here? You know that you can easily factor out this one using is it the computing the square method or the factor method?
Product and
Sum and product, right? So when you factorize this one,
yes.
x plus 6 open close x minus 4, isn't it? Now when you notice here, x plus 6 is on top, right? And
Yes.
down here there's x plus 6. So these guys are common, isn't it? So we can easily cancel the one on top and the one on the bottom, right? And then we remain with this new function,
Oh, yes.
x minus 3. Now, we focus on this new function. What's the vertical asymptote for this function?
It's 4.
Yeah, it's for this. So the vertical asymptote, for which is
Yes.
now, you know that you have not the whole which is taking place, isn't it? Because you have found isn't it? Which means that there is the whole which is taking place. Now, where is the whole taking place? This is how you find for the whole, isn't it? The whole is taking place when x is equal to negative 6. So now, when you plug in negative 6 here, isn't it? You find that you have a 0, right? Then 0 times this can find, isn't it? But the it's like it's common on both the numerator and denominator, so we can easily cancel it.
Dorcas, mute your mic.
Okay.
So in short, what we are saying that since we have common terms here, our whole will take place at negative 6. I don't know if you are able to see it now. So here our whole is taking place at negative 6. Now, how do we find the value of y if we discover that when x is negative 6, where the whole is starting from? What would be the point where the whole will take place? So we take the negative 6. Plug it in this new function here. We have negative 6 minus 4, isn't it? Which will give you what?
Sir, I don't know if there is a problem with your microphone, but your voice is low.
It's the people whose mics are not muted. That's why.
But then people
Okay, are you able to get me now?
Yes.
All right, we'll proceed now. So here I was saying that we have the common terms here, isn't it? X plus 6 and x plus 6 down here. So we can cancel this guy. Now, those values you are canceling now, that's what we are calling a whole, isn't it? So now, since they are common in both the numerator and denominator, we'll create a new function here, which is 1 over x minus 4. Now, this new function here, how do we find the vertical asymptote? We equate this guy equals to 0, and so for x, we discover that the vertical asymptote is 4, right? So now, when you discover that your vertical asymptote is 4, you know that the values which will correspond to a whole is to take place at x is equals to -6. When you plug in -6 here, it will be undefined. But when you plug it in this new function, it will be defined, isn't it? So you know that your whole will take place at what is -6 minus 4?
-10.
-10, right? So you know that at -6 comma -1 at -6 comma -1 over at 1 is it -6 comma -1 over 10, isn't it? That's why your whole will take place. Huh? So when you look at this guy here, this simply tells you that the whole will happen at this point, -6 comma -1 over 10. And now seeing the pattern on how to solve this question 1.
Yes.
Okay, so we proceed. I think we go to question 2. Huh? We now focus on the horizontal asymptote. Yeah. So now, the thing to remember about the horizontal asymptote is that when these powers, when you have, for instance, the degrees of a polynomial, isn't it? Let's say you have x to the power 2 and x to the power 2 down here, isn't it? So this simply tells you that when you're finding the horizontal asymptote, you just equate this 15, this coefficient, isn't it? 15 over 3. But when your coefficient on your what's this, on the numerator is less than the one on the denominator, you know that you don't have the vertical asymptotes there. And then another thing you should remember is that when the what's this, the degree of a polynomial on the denominator is higher than the one on the numerator, that's going to tell you that the horizontal asymptote is always 0. I don't know if you have gotten that point, but I'll explain this. So when
No, so I explain, yes.
okay, so we have something like this. So here I'm saying that when the degree, let's say this is the numerator, right? Numerator over denominator, right? So now when the power of this guy here, the power, isn't it? When the power probably is it greater than this guy, the power which is on the denominator, isn't it? When the power for this one is greater than the one on the denominator, your horizontal asymptote, isn't it? Your horizontal asymptote will be equals to what? When the power on the numerator is greater than the one on the denominator, your horizontal asymptote is simply to have this function will have no horizontal asymptote, isn't it? Because the power on the numerator here is greater than the one on the denominator. We'll look at this type of function. We call them the slant asymptote. But for now, we're not focusing on those. We're looking at horizontal asymptote. But when your numerator, the degree of a numerator is greater than the one on the denominator, isn't it? That tells you that your horizontal asymptote, there's just nothing, no horizontal asymptote here. There is nothing here. There's no horizontal asymptote. No horizontal asymptote. But when the degree of your numerator, right, is less than Yeah, well, your degree of the numerator is less than the one on your denominator, right? So which simply tells you that your horizontal asymptote will be equals to 0. When this degree of the numerator is less than the one on the denominator, the horizontal asymptote will be equals to 0. Now, here the key concept is that imagine you have got probably on the numerator, isn't it? You have x, x over x squared, right? So we know that this guy can be written as is equals to 1 over x, isn't it? 1 over x. So when you notice that as x approaches infinity, isn't it? We'll be approaching to 0 because let's say if you take 1000 divided by 1, you have something like 0 point something here all the way, isn't it? So that's why we're saying that when the degree of the numerator is less than the one on the denominator, your horizontal asymptote, it's always going to be a 0. Now, when you have this situation where you have the powers are equal, isn't it? So now when the powers are equal, both on the numerator and denominator, like in this case, the one we are solving right now, we discover that when the powers are equal, we just have to equate this coefficient which we are having here. We don't concentrate much on this one because it won't change anything, isn't it? Because anything big plus like a small number like 1, it will still be big, isn't it? So when we just concentrate on this powers, which is x squared and x squared, concentrate on the coefficient. So 15 over 3, isn't it? So we take this 15 over 3 and we say 15 over 3, which will give us 5, right? So that 5 is what we're calling our horizontal asymptote. Is it now clear?
Yes.
Okay. So that's how you find your horizontal asymptote there. Because in that question we're just finding the horizontal asymptote. So it means you're done and you get your full marks. Sorry. So now, when we look at question 2C, when we're finding the horizontal asymptote, like I said here, the power of this guy is greater than the one on the denominator. So this simply tells you that there is no horizontal asymptote on this function here, since the power on the numerator is greater than the one which is on the denominator. So that simply tells you that this function has no horizontal asymptote, but it's a slant asymptote. We will focus on that on question probably 4 somewhere there. But this one, we just conclude to say that there is no horizontal asymptote. Is that clear, please?
Yes.
Yes, it is.
Yes, it's clear.
All right, proceed. So we go to question 3. Question 3 is telling us that use transformation of the function f of x is equals to 1 over x, or f of x is equals to 1 over x squared to graph each rational function. So now this is where the graphing will take place. So you know that when you're using transformations, we have been given this function here, g of x, which is equals to 1 over x minus 2. And when you notice that we're using transformation, so transformation is simply change, isn't it? Like a shift of something, isn't it? So when we say f of x is equals to, we use this one, since here our power here is 1, isn't it? So here as well there's 1, right? So when we substitute, isn't it? When we say x minus 2, we plug it in this function here of ours, it will be equals to g of x. That thing really holds. You can even try to verify. So now when you look at this guy here, your vertical asymptote will take place where? You know how to find the vertical asymptote by now. You know that you have to equate this this denominator equals to 0, then we solve for x. So now when we solve for x, we're getting that our vertical asymptote is 2, isn't it? Now, how do we solve for horizontal asymptote? What's the horizontal asymptote for this function here? You notice that the degree on the denominator is greater than the one on the the numerator, isn't it? So your horizontal asymptote is simply 0, isn't it? So now when you are graphing this function, this function in a graphing. So now, since we know that our vertical asymptote is 2, isn't it? So we draw the line here. We draw a line here. We have this line here, which is 2, isn't it? The vertical asymptote. So now, when you draw this line, which is your vertical asymptote, pick a number. Okay. So when you draw a vertical asymptote, you pick a number which is greater than 2. Let's pick 3, isn't it? So now when you pick 3 here, isn't it? So this line is coming from positive infinity, trying to approach this vertical asymptote, isn't it? So we always start with this line, going this way, isn't it? So when you pick 3, here we have to
Sir.
Yes, come again.
So,
Yes.
can you please repeat on how you found the vertical asymptote to be 2?
Okay. So the vertical asymptote, when you look at this function here, the function we are solving, isn't it? It's this one, right? So we equate this guy to 0, isn't it? Then we solve for x. You know that the vertical asymptote, those are points that to make the function to be undefined. So when you say x minus 2 is equals to 0, what will be your value for x? Hello?
2.
You have seen it, eh?
Yes, so when you are dealing with vertical asymptote, you deal with the denominator, and for horizontal, you deal with the denominator, the numerator, I mean.
Yeah, for horizontal, you are looking at both the numerator and the denominator. And we have to look at the pattern. So you have to concentrate on the powers. So now, if the powers are equal, both on the numerator and denominator, so we get that polynomial with the highest power, we get the coefficient of those two polynomials with the highest power, then we equate them to say, since it's a numerator and denominator, let's say if the coefficient is 1/1, our horizontal asymptote there to be just 1. So like for horizontal asymptote, there's like a trick which you must not forget.
Okay, sir.
All right.
Sir,
Yes, please.
Before you go, can we repeat on how you started the transformations there? How we ended up with g of x is equals to 1/x minus 2, then to g of x is equals to f of x minus 2 there.
Okay. So when you notice that we're using you're using this transformation here, right? Okay, you can mute your mics, please. So now, when you notice that we're dealing with this function, okay, so when you're dealing with this function, you notice that this guy on the denominator x minus 2, isn't it? When you plug it in this function here, it will give you a g of x, isn't it? So that's why we're saying that when you have f, the function f, isn't it? When you plug in x minus 2, it will be equals to g of x. This one it hold. That's how we start the transformation. So you notice that x minus 2 here, this simply tells you that we're shifting from the origin. We're going, you know, like 2 steps.
sir,
Yes.
but like when you plug in x minus 2 in this 1/x, like won't it be 1/x minus 2? Why are you just writing x minus 2?
Yeah, it will be 1/x minus 2, which is equals to g of x. Have you noticed that?
Yes.
Yeah, so that's why I'm saying that g of x is equals to f x minus 2 there.
So like, is this part necessary?
I'm not sure though.
All right.
But more of like you're just showing the transformation that is taking place between f of x and g of x, isn't it? That's the transformation which is taking place here. You're just showing. Have you gotten it?
Yes.
Now, sir, yeah, you said when you plug it in, it will be g of x is equals to f of x minus 2. Now, where is the f of x minus 2 coming from?
They are saying that use the transformation. We're trying to use this fact. So no matter what you do in mathematics, you just have to use this fact which is here. So, you know, like this thing can also carry half a mark. Just showing this part here, isn't it? It can carry half a mark because you're using the transformation. The question is, use the transformation of f of x is equals to 1 over x to graph each rational function. So I've used this fact here to say g of x is equals to fx minus 2. So I've used the fact that you have been given, because everything that you have been given, you have to use it. Have you gotten it?
But how is the horizontal?
Yes.
How is the horizontal asymptote of the numerator greater than the one of the denominator when you say it deals with the powers?
What is x here? It's x to the power 1, right?
Yes.
Now, what is x here? It's x to the power 0, isn't it?
Oh, yes. Okay.
I've seen it.
I get it now.
All right.
Yes.
So we proceed now. So you know that our horizontal asymptote is here, isn't it? Now we have shifted 2 times, like we have gone to say our vertical asymptote here is close to 2. So I've gone this side. We have shifted 2 times, isn't it? So now this becomes our new, more of like our new vertical line, isn't it? Here. But you know, one thing is that in this line here, your graph can't cross the horizontal asymptote, but sometimes it can cross the, so your line can't cross this graph here, can't cross the vertical asymptote, but sometimes it can cross the horizontal asymptote, because if it crosses this vertical asymptote, the function will be undefined, isn't it? Because imagine if we were to graph this, whereby this graph is coming from positive infinite, when it crosses the horizontal asymptote here, which is 2, isn't it? We know that when x is 2 here, this function will be undefined, isn't it? So no matter what you do, your graph must never cross the vertical asymptote, but it can cross the horizontal one. So now when you look at this guy here, we know that when we picked 3, isn't it? You notice that when you put 3 here, it will be 3 minus 2, which is 1, 1, isn't it? And when you notice here, when you pick 3, our x, it will be 3, our y will be 1. So it simply tells that your graph, it will go upward. It won't go downward. This is just a rough sketch. You can have many or multiple values which you can pick. So you notice that your graph is coming from this way. When it's trying to cross this vertical asymptote, it won't really cross it through, but it will go up, isn't it? Yes, go ahead, please, Natasha. Yes, Natasha. Yes, Natasha, what's the question, please?
Continue.
Yeah, just continue, sir.
All right, so here we have noticed that when we pick 3, probably 3 could be somewhere here. It's coming from this side, the line is coming from this side. Then when it tries to be, when it reaches here, it can't cross the vertical asymptote, right? So it will be, when you pick 3, our value for y, it will be 1. So it simply tells that it is going to the positive side here. It will be going up to probably positive infinite, right? So now, how do we pick other points? So I've picked one value from this side of the vertical asymptote. Now we pick another value from this side of the vertical asymptote to your left hand side. So now here we can pick positive 1, isn't it? 1 is this side, isn't it? So the graph, this graph is coming from this side. approaching this vertical asymptote here. So I've picked one. So you realize that when you pick one, you plug it in here, you discover that it will be 1 minus q, isn't it? Now, 1 minus q simply gives you -1. -1 divided by +1 is simply -1. So now it will show you that this graph here, when you pick one here, it will be going downward. It will be going to the negatives. So it will be 1, -1, which is here. Simply tells you that this graph, it will bend toward this, but it can't touch this vertical asymptote. So it will go like this down here. So that's how we come up with this sketch for question 3, the use of transformation to graph each rational function. Is that clear, please?
Yes.
Okay, let's proceed. Okay, so the same concept here. When you look at this one here, isn't it? This function here. This function has no vertical asymptote, right? But it has a horizontal asymptote, which will take place at 2. Because here we have something like 1 over x plus 2, right? You know how to find the vertical asymptote of this function, isn't it?
No.
No, sir.
All right.
The vertical asymptote, since
Can't you
the
just equate
numerator,
To 0, isn't it? So now you know that it's taking place at 0, isn't it? Because we can pick any value for this.
So how do you find that 0?
This one here.
Yes, sir.
When you look at this function, 1 over x plus 2. Now, what value can we put for x that will make this function to be undefined?
Zero.
Yeah, so that's where
0.
it's coming from. I don't know that, the vertical asymptote, these are just points that make the function to be undefined. So now for the horizontal one, you remember that we are concentrating on this power, it's greater than the one on top. So it will be this, when this guy gets bigger, this one will be smaller, right? So it will be approaching 0, isn't it? So when you say probably 1000 divided by 1, it will give you 0. So now here there is a 2, right? So it will be 0 plus 2, it will give you your horizontal asymptote, which is here. Yes, go ahead, please, Mr. Isaac.
Okay, sir. The vertical asymptote have said it's 0.
Yes.
So doesn't it mean that since the vertical asymptote it passes through the x-axis, so doesn't it mean that when we say the vertical asymptote is equal to x is equal to 0, doesn't it mean that it is the y-axis, because the y-axis is where x is equal to 0? Doesn't it mean that the y-axis is the vertical asymptote in this case?
Yes, that's what it means, yes.
Okay. But why is it not dotted if it is the y-axis which is the vertical asymptote?
Yeah, the issue is that when you're graphing, you have the y-axis, isn't it? So there's my dotted line here, which I was showing. I don't know if you're able to see these lines, showing that there's a vertical asymptote passing there, isn't it?
Oh.
Yeah. But we don't.
Okay, so it's...
Yes, please.
We don't
really disturb this the y and the x intercept. We just dot my dotted line alongside it, showing that there's a vertical asymptote on this y axis.
Oh. Okay, I've understood. Yes.
So we now proceed. So since we know that the vertical asymptote is 0 and the horizontal asymptote is 2, we now graph our function, isn't it? You know that.
How have you found the horizontal asymptote?
Horizontal. You remember that we're looking at powers on the numerator and denominator, isn't it? So now what will be this value here? Let's say if you put positive probably. Let's assume. Let's say, let's pick 50 for instance. What is 50 divided by 1? It will give you something like 0 point something something. So when this x approaches infinity, isn't it? So, so you notice that when we pick the large number here, let's say when x approaches infinity, this function here, it will be equals to 0. But when we say 0, there's a number here, isn't it? So it will be 0 plus 2, which will give us our horizontal asymptote. This is where the 2 is coming from. Have you seen it now?
No, no.
No, I don't understand.
Listen, what will be the value for this function here? Remember what I said earlier on to say that when the power of the denominator, isn't it, is greater than the 1 of the numerator, your horizontal asymptote here is simply 0, right?
Yes.
Yeah, so you know that here it's 0, isn't it? Now, what is 0 plus 2?
2.
It's 2. This is why we're getting this line here, the horizontal asymptote, which will take place at 2. Because here the function is like, we have added the 2 here. So we can't ignore this 2. We have to use it. So here when there's a 0, so it says 0 plus 2, we get the horizontal asymptote to be 2 here. We proceed. So you know that the horizontal asymptote, it's 2, which is taking place here, right? And then for the transformation, you know that the h of x is simply equal to f of x. Remember that f of x is equals to 1 over x, isn't it? So it's f of x plus 2, which gives us our transformation here. So now when graphing, we have this vertical asymptote and the horizontal asymptote there. And then you know that when graphing 1 over x, 1 over x, it simply starts from somewhere here all the way to there. But now we have shifted it. It's starting from here, isn't it? There's a shift which has taken place, the transformation. So we start from here. Imagine that this is where your point of, this is where 0 is now, isn't it? So we'll start from here. So when we pick any value, isn't it? If you pick any value from here, let's say 1, isn't it? Let's say 1. Now, since our line starts from here, if you pick 1 this side, which is the positive, when we put 1 here, to be 1 plus 1, here to be 1 over 1, which is 1 plus 1, which is 3, isn't it? So your vertical asymptote, it will be 1,3. Now, where is 3? 3 is on top here, isn't it? So when we're approaching here, you have picked 1, isn't it? So it's coming from this side. Here is your vertical asymptote, right? So 3 is somewhere on top of the 2, isn't it? So the graph will bend, it's going upwards. So when you can pick more values to even sketch it better. So when you go to this other part here, your left hand side, so you pick probably -2, isn't it? So let's just pick since negative, yeah, -2 is fine. Let's pick -2. So when you pick -2, we plug it in here, isn't it? So it should be 1 over negative, but still be at manipulation. Let's just use -1. So we have -1 over 1, which is negative, what's this? Let's see. -1, right? So it will be -1 plus 2. What's that?
1.
1. So here, pick -1. No. You can't pick anything less than 2. You've gotten it?
Yes.
Are we clear, please? I think I made the mistake there. It's our horizontal asymptote, it's 2, isn't it? So we can't pick anything less than 2, isn't it? So we pick something greater than. So we have something like when you pick negative 3, which is this side, isn't it? We have something like 1 over negative 3. When you do the manipulation, the graph, when it's approaching this side, it always goes down here because we shifted it. If you remember the graph for 1 over x, the graph for 1 over x, it's like this. Simply like this, like that, and like that, isn't it? But here in our case here, we have shifted this graph twice, we have gone up, isn't it? So it's simply, the standard will be the same. Here the standard will be the same. We're just shifting it up this side. So when it comes this side, it goes down again. Then here, when it's coming this side, it goes up. Is that clear though? Hello, is it clear on this one?
Yes, it is. So you're saying for both the horizontal and the vertical, you always have to pick that is the number that is greater than 2.
Yeah, something which is greater than. So, but what you should keep in mind that for this one, we're just shifting it, we're just adding a 2. But if you remember how to graph this, isn't it? You realize that when you, let's say if we're graphing 1 over x, right? You have something like here, when you pick the positive side, it will be 1 over 1. You have 1 over 1 there. If you start going this way, isn't it? Like 1 over 1, when you pick 2, there, isn't it? So it will be 1 over 2, isn't it? So it's like the graph will be like this. Yes.
But negative 3 is less than 2.
Yeah, that's what I'm saying is that for this one, we maintain the graph, which is this one, isn't it? For this part, plus 2 here. For this part, plus 2, it's like we're just shifting it, isn't it? We're shifting the origin, the transformation.
Okay.
So in short, our like we've shifted it from here, which is 2. So here is where our origin is now. But what is the graph for 1 over x here? 1 over x. We discover that the graph 1 over x, it will be going that way. And that way, when you plot the value, since we have shifted the origin now, it's here now. We proceed. Okay. Okay. So now we go to this one here. Question 3C. Now, when you notice that this function here, g of x is equals to 1 over x, right? Now, we're using this, the transformation of this guy here, x squared, right? 1 over x squared, isn't it? So now, when you know that the transformation of 1 over x squared, when we say g of x is equals to f x plus 1 over 2, which is the same as the function f, which is the same as 1 over x squared. It will give you back this function here. Now, for vertical asymptote, we equate this function here to 0. We discover that the vertical asymptote is -1, but this function has no horizontal asymptote. The horizontal asymptote is 0, sorry. So now, when the horizontal asymptote is 0, we're simply telling you that we're shifting this graph here. This is 1 over x squared, isn't it? We're shifting it, right? So this guy here will be our origin, which is -1. So now when you are graphing this guy here on top, this one on top, when you pick some values, isn't it, which are greater than probably, let's pick 1, isn't it? You discover that there is a squared in this function here, which simply tells you that our function will always go up, isn't it? Because even if you pick negative or positive, the value that will be outputted, it always be a positive. So this function, it's coming this side. Even if you pick negative 0 point something, when it's supposed to approach this vertical asymptote, it will go up. And then when it's coming from this side as well, the negative side, even if you pick negative 10, the function can't go down here. Since here we have a squared here, it will always go up. It's always going to be the positive side, unless like this, it's going up like that. Is that okay, please?
Yes, it is.
We go to, for the remaining graphs, I think to do the manipulations. I've never been a fan of graph, honestly speaking. So we go to question 4. So question 4 is,
Someone skips that one. Explain.
okay. So there's this one.
Yes.
So now we know that the vertical asymptote, we equate this guy to 0, isn't it? So we have x minus 3 open to the power 2, right? We find that the vertical asymptote will take place at 3, isn't it? Because when you put 3 here, the function will be undefined, isn't it? Now, the horizontal asymptote, since the power on the denominator is greater than on the numerator, when we know that the power on the denominator is greater than the one on the numerator, this simply tells you that the horizontal asymptote of this guy, it's 0. Now, 0 plus 1, we're having this one here. So now when you have this one here, when you look at our graph, our vertical asymptote is 3, isn't it? So it's this side, right? And our horizontal, it's 1, isn't it? So we have shifted from this part, from this point of origin, we have a new one here, isn't it? So now when you have a new one there, we're now trying to graph it. So if we pick a positive number from this side, so when we pick a positive number, let's say positive 4, when we plug it in here, we have 4 minus 4, which is positive, isn't it? So here we always get positive values, isn't it? So which simply tells you that our vertical asymptote will go up, isn't it? It will go like this. The moment it tries to approach this guy here, it will go here on top. So now when we pick values now to the left hand side here, isn't it? Let's say if we pick 0, for instance, which is here, right? When we plug 0 in here, we have 0 minus 3, but what is 0 minus 3 to the power squared? It will be positive again. So that simply tells you that our function here to is going up as well to the positive side. Is that clear, please?
Yes.
Yes, Mr. Moses, is that a question?
Oh, so that's what they mean.
So what of that power?
Which one?
That squared, is it squared or 2 squared? That one, x minus 3 to the power 2.
Yes, it's a
By
square.
the numbers, how do you call it?
Just to ignore it, not to, or do you expand it like
No, just use it the way it is. You can easily pick values for x, right? It will be even much easier because when you expand, you'll be like complicating your life. So let's pick probably -1. So when we put -1 in here, we have -1 minus 3, which is -4. When we square it, it will be positive. So it simply tells you that these values here, they're always heading toward the positive side. It's going on top, it's coming from this side. When it can't cross this line, the vertical, so it will bend upward, going to positive infinite. Is that clear, please?
yes, sir.
All right, we proceed. What time is your class, please?
It was going around 8 to 8.
9 hours. So It's not likely to be there since he just posts videos on Moodle.
All right, then you let me know when we proceed. So we go to question 4. On this question 4, it's just telling us that sketch the graph of each rational function, isn't it? So we've been given this rational function here, which is question F. For the remaining ones, you'll be doing them. So question F, we have negative 2 over x squared minus x minus 2, isn't it? So for this function, we can factor out the negative. So now the negative on top on the numerator can cancel with the one on the denominator of this function here. Now, when we do the factorization of that function, we'll get this one. It will be 2 over negative x plus 2 open cross x plus 1. Now, when you have question 4, you have to find a lot of stuff, isn't it? You have to find your x-intercept. You have to find your y-intercept when you're graphing this rational function. So now, your vertical asymptote here, since the power here we have, when we equate this guy to 0, isn't it? You have two values. We have negative 1 and 2. That will be your vertical asymptote. Now, your horizontal asymptote, since the power on the denominator is greater than the one on the numerator, your horizontal asymptote is 0.
Sir, kindly repeat on eliminating this negative.
You have noticed that there's a negative on top. So it's no most of the time negative, they disturb us a lot, isn't it, when they're on top? So we don't want. Now you have noticed that there's a negative there and negative there. So we can factor out this negative, which is here, isn't it? So we have something like a positive there and the positive. This x has no negative, right? So it will be negative. So we have negative and the negative. These guys will cancel, isn't it? So we have this new function here. Is it okay?
Okay. Yes, thank you.
Yeah. So now when you find those sum product, you find that it will be negative x plus 2 open close x plus 1. This is our, when we expand the negative x squared plus x plus 2, you find this these two factors. So now your vertical asymptote are those values that you make the function to be undefined. So now when you notice that this guy is here, you notice that when we plug in positive 2 here, it will give us a 0, right? Then you know that when you have a 0 in the denominator, it is undefined. So we have known that positive 2 is our what? Our vertical asymptote. So now when you plug in negative 1 here, this function will also be undefined. So we also know that negative 1 is also our vertical asymptote. So we have two vertical asymptotes. So now for the horizontal one, you have noticed that the power on the denominator is greater than the one on the numerator, right? So that simply tells you that the horizontal asymptote will be 0. So now when graphing now, you have two vertical asymptotes, right? So you have negative 1 and positive 2, isn't it? So these two lines are going this way, isn't it? So now when you find your y-intercept, so y-intercept, we say that x is equal to 0, isn't it? So when you plug in 0 in this function, here, when you put a 0 on x and x here, you have a 0 there and a 0 there. So it will be 2 times 1, it's 2, isn't it? So 2 divided by 2. Here your what's this? Your y-intercept will happen at 0, 1, isn't it? Is it okay there? Yeah, so for the y-intercept, it will take place there. Now, what will be your x-intercept? So you know that x-intercept, we have to equate y to 0. Now, when you put y is equal to 0, this function will be undefined because it will be 0 times everything here, which will be equal to 0 is equal to 2. So this function has no x-intercept. So we just have the y-intercept, which will take place at 1 here. So now, when you look at this guy here, you can plug in those points you have now, isn't it? So you know that you have 0, 1, right? Which is your y-intercept, isn't it? Is it okay, please? So now when you have noticed that you have 0, 1 here, which is y-intercept. So here in this region, we can pick probably 1, isn't it? In this region, let's pick 1 this side. So when we pick 1, we plug it in here. We have -1 plus 2, which is +1, right? Then this will be positive, isn't it? So it simply tells you that this function is adding to positive, isn't it? So here you have noticed that your y-intercept is 1, isn't it? So your graph is starting from here, where the interception is taking place. Then it will start going to the positive side. Because if you pick values here, let's pick on this side, we can pick probably -0.5, right? So when you pick -0.5, we plug it in here, it will be positive, isn't it? So negative times -0.5 to positive 0.5 plus that, which is positive. Then -0.5 plus 1, it is still positive, isn't it? So you notice that this function, it will go upward. Again, when you go in this region here, to go upwards, isn't it? Now we go to this part here. Let's pick -3, isn't it? You have noticed that -3 is greater than this one here. If you pick -3 in this region, right? If you plug in -3 here, it will be positive, isn't it? It will be positive. It will be +3 plus 2. Now here it will be -3 plus 1, which is -2, isn't it? So negative times negative. So you have something like this. So you have something like positive. Here we have a positive, right? But here we have a negative, isn't it? So now that here it's positive, right? Here we have positive times negative. It will give you what? It will give you negative, isn't it? Then positive, the positive, it will go down, right? To come here. So when we divide the negative and positive, we are getting what? This guy will be equals to negative. So you have noticed that our graph in this region is going to the negative part. So I've noticed that when we pick -3, our graph will be going downwards to a negative, isn't it? Hope you have seen it. So we're coming from this side. Our graph will go downwards to the negative. So now when you go to this region here, let's pick 3, isn't it? In this region, let's pick value of x to be 3. So you discover that when we pick the value of x to be 3, so here it will be -3, right? -3 plus 2, which is -1, isn't it? Which will be -1, isn't it? So here it will be 3 plus 1, which is positive. So it is negative times negative, which will give us, it will be negative times positive, it will give us negative, right? Then negative divided by positive, which is on top, which is +3, it will give us negative again. So you have noticed that when you're coming from this side, if you pick 3, isn't it? When it approaches this vertical asymptote, the graph will bend down since it is given as negative here for the y values. Is it clear, please?
No, sir.
No.
Okay.
No, from the beginning.
So let's concentrate
It's
on
very complicated.
Okay, let's do it again. You have noticed that this function here, isn't it? Hope you're able to see it. So when let's start with this one again. Let's speak in this region. You have noticed that there's this part here. There's this region. You're able to see it. This region here, it is defined, isn't it? But it's not defined where there is this vertical asymptote and that guy. We can't cross these two lines, isn't it? So now we have our y-intercept there. Let's pick 1 here. Let's pick +1, isn't it? In this part here, since there's this line which is our y-axis. But if you pick 1 here, +1, you discover that when we put +1 here, if you put +1 here to be -1 plus 2, isn't it? So here we have something like a positive, right? So -1 plus 2, it's positive, isn't it? So now 1 plus 2, it still be positive, isn't it? Now on top here, this 2 is positive, isn't it? Now, what is positive divided by positive? It will give you positive. So that gives you an idea that your graph, this function graph, it will start going where? To the positive side. On this part, when this is the intercept, Y-intercept. So when this graph is approaching this vertical line here, to start going up, it won't go down. Since we've picked the value here, which is 1, and it has given us something positive here. So this graph will go in, it's going to go up. So now we're going to pick another value on this left-hand side. I'm trying to approach this guy here. So when you pick another value on your left-hand side, you have something like here. When we pick another value, let's pick negative 0.5. Okay. So when we pick negative 0.5 in this region here, you discover that if we put negative 0.5 there, isn't it? If you put negative 0.5 here, this guy to be positive, right? Negative 0.5 times that to be positive. Positive plus positive, still positive. So we have positive there, right? Then now here we have negative 0.5 plus 1, which is still positive because negative 0.5 plus 1 is still positive 0.5, right? So we have positive there again. So on top here, the 2 is positive, isn't it? Now, positive plus divided by positive, it is still positive. So that simply tells you that in this region as well, isn't it? In this region here, our graph as well, when it's starting, this is the point here, to start going to the positive side, it will be going up, but it will never touch the vertical asymptote. Is that clear on this region here?
Yes.
Okay. So now we concentrate on this other one. We go to the other part, isn't it? Because it's like there's some division of parts, isn't it? So we go to this part here. Let's pick a value which is greater than negative 1, which is here, isn't it? Let's pick negative 3 or negative 2. So if we pick negative 3, like I said, isn't it? We pick negative 3. So we have something like to put negative 3 here. If negative 3 times negative which is outside here. So it will be negative 3, which is outside here, times the negative, which is here. We have positive. Now, positive plus positive is still positive, isn't it? So we have positive there, right? Now, negative 3, isn't it? Plus 1, it's simply negative, isn't it? So it will give you negative 2, right? So we put negative there, isn't it? Then here there's a positive 2, right? So now, positive times negative, it will give you what? It is giving us negative, right? Then positive here to be on top, right? So now when we divide negative divided by a positive thing, now it will give you something like negative, isn't it? So when you divide the negative here times divided by a positive thing, this value here, what is be equals to something like a negative thing, a negative number. So now when you look at our graph here, isn't it? So we have noticed that if we pick a negative 3, isn't it, in this region, right? We have picked a negative 3 in this region, isn't it? We are coming from this side. It's negative 3 we have picked. So when it's twice to approaches the vertical asymptote, since the value that we got, it was negative, so it's simply going to the negative side for the y values. Is it clear, please?
So you should post the video when you're done.
All right, no problem. But the key figure here is simple. You have to notice that there's no need to plug in a lot of values. You just have to, you can even pick one value or two. Let's take this part for instance. If you pick positive 3 here in this region, isn't it? We're coming from this way, isn't it? We're approaching this vertical asymptote here, which is 2, isn't it? We can't cross this, and so now I want to discover where our graph bends to. Is it going to go up or down? So how do we find out where it bends to? We come here, isn't it? we have picked positive 3, isn't it? So now you notice here, when we put a 3 here, isn't it? It will give you negative 3, right? So here we have negative 3 plus 1, which is negative 1. And then here it will be 3 plus 2, it will be positive, isn't it? To be positive 4, right? And then here we have a 2, isn't it? So when you say negative, here there is a positive 4, right? So here, since there are 2, isn't it? So it's negative 1 times the positive 4. This guy will give you negative 4, isn't it? Over this guy, it is positive, isn't it? So you have noticed that your y value here, it is negative, isn't it? Because when you reduce this guy, you have something like 1 over 2, isn't it? Which is negative here, isn't it? So when you notice that in this graph of ours, we have picked positive 3, right? So we have noticed that the y value, it will start going down here, since negative half here, isn't it? So it will start going down here. So it simply tells you that the graph will be bending downwards. Is it clear, please?
Yeah.
Clear now. Oh, do I have value? Right.
We do another graph. We do this one. So you have noticed that this function has no vertical asymptote, which is 4G. The 4G has no vertical asymptote. Reason being that when we equate this guy to 0, we have the one who comes this side. So which will be negative 1, isn't it? Now the square root of negative 1 is a complex number, isn't it? And then we're dealing with rational function here. Rational function are just real numbers. We're not dealing with complex numbers. So the vertical asymptote for this function, there's nothing. But we can find the horizontal asymptote. Since these powers are equal, right? We have noticed that x to the power 2, and here we have x to the power 2. We can divide the coefficient. So we have 4. So here we have 4 over 1, isn't it? So 1 into 4, it simply gives you what? The 4, which is here, which is our vertical, which is our horizontal asymptote. Is it clear, please?
Yes.
So now, when you are graphing this, since our y is equals to what? Our horizontal asymptote is positive, so it's up here, isn't it? So now, when you are graphing this function, isn't it? So now, let's pick that we have x squared here, isn't it? And x squared down here, isn't it? So now, if we pick values, let's pick values in this region, isn't it? Let's pick positive 1, for instance. So you notice that when we plug in positive 1 in this function here, this function will never go down. Since x here, so it's squared, isn't it? So even if you pick any values, here where is a positive, isn't it? This function, where is b equals to the positive side, it will always go up. You have seen. So you have seen that if you pick probably positive 3 or positive 4, you discover that imagine this guy here, you have something like we have something like here there is probably 1, a 2, a 3, a 4, right? And then here we have a negative there, and the negative 2, isn't it? And the negative 3, isn't it? So now, whatever value you pick in here, isn't it? Your graph, first you remember that you have to find your x and y intercept, right? Now, how do you find your x and y intercept? You equate this guy first, isn't it? To be equals to 0.
Where are you writing? You can't see anything.
Huh? You can't see.
That.
Let's do this. So we were here, isn't it? But remember that we can first find this two, isn't it? You first find your x-intercept, right? Which is 0, 0, because when you multiply this guy by this, it will give you 0 is equal to 4x squared, isn't it? So you find the x-intercept, your y-intercept again, it's simply 0, isn't it?
So we still can't follow you. What I'm
Kanji,
seeing
sir,
is
how do you find the
right hand here.
intercepts there?
The intercept, you're able to see that for y-intercept, you know that the y-intercept, we say x should be 0, isn't it? Are we okay there?
Yes.
Yeah, so now when
Yes.
we put a 0 here, isn't it? So x is 0, isn't it? We put a 0 there, right? And a 0 there, right? You discover that this guy to be 0 times 4, which is just 0, right? So now 1 divided by 0, it's simply 0, isn't it? Are we okay there?
Mm-hmm.
So we know that
Yes.
when we plug in 0 for x, our y, what should be our y? It should be still be 0, isn't it? So that's why we're having this guy 0, 0. That's the point, right? Now, for finding the x-intercept, our y is what? Our y would be 0, isn't it? So now, when our y is 0 here, we can multiply this 0 times this guy. We have our function to be like this.
Sorry, sir, for disturbing. I don't know if I'm the only one who finds whatever you're doing. The
Huh?
screen is stuck.
The screen is what?
The screen is stuck. It's
The
stuck.
screen,
I can't see anything.
No, it's only you.
you're able to see.
I'm able to see. I
Alright.
think just try to check
Okay.
your phone properly.
So here, when we multiply this thing here, we have something like 0. We're finding for x-intercept. 0 is equals to 4x. 4x squared, isn't it? 4x squared. So now when we divide this code both sides, we discover that x is equals to what? Is equals to 0. So now what is our y? Our y is also equals to 0. So our x-intercept is 0, 0. So now in our graph here, so you have noticed that in our graph here, the intersection point is taking place here at 0, 0, isn't it? So now when you are here, it simply tells you that when you are graphing, now when you pick values, let's say we pick 3, I can even show it here. If we were to pick, if you pick 1, 2, or 3, you discover that this graph of ours, it is going, it's always going to be going upward, isn't it? Since our function here, we have a squared here, isn't it? And a squared down here. So no matter what you do, you can never make this graph to bend downward to a negative, because even if you put a negative value in this function, it is going to be a positive thing, because negative 1 squared is simply positive 1 squared. Or you can pick any negative, it's still going to be a positive thing. So you discover that this graph of ours, it will start from here at our point of intersection, right? Then when it starts going up, let's say if you pick 1, you find that our y value here, probably if you pick 1 there, you find that it will be 1 plus 1, which is 2, isn't it? Then here you have 4, isn't it? So now 2 divided by 4, it is 2, isn't it? So you discover that our value here to be 1, 2, probably 2 could be somewhere here. So our point here to be here, right? If you pick 2 again, our point will be somewhere here. You discover that the graph will be bending toward that. Not necessarily crossing this horizontal line here. So it will be bending like that. If you pick the negative as well, it will start bending like that. Is that clear, please?
Yes, sir.
Thank you. We proceed. Question 4. Question 4. Question 4, this is I think J. Question 4J, which talks about x squared minus 4x plus 3 or over x plus 1. We have been told to graph this function. So the first thing that you can do on this type of function is that you can simply expand the top part. So you have x minus 3, x minus 1 here. So now when you have this this expansion here, we can find now the vertical asymptote. So the vertical asymptote is simply those values that makes this function to be undefined. So we have x plus 1 squared is equals to 0. So when we get rid of this root, you discover that we have x plus 1 is equals to 0. So the 1 will go that side. So the vertical asymptote, it will be -1, which is here. Now, what will be our horizontal asymptote? Since we have noticed that the powers on the denominator, right? This is x to the power 2, right? Then also you have x to the power 2, isn't it? So it simply tells you that the powers are equal, isn't it? So we equate the coefficient. So since the coefficient for this power here, the coefficient for this power here, it's 1, right? And the coefficient for this x squared, which is in here when you expand it, is still be 1. So in finding the horizontal asymptote, we say we equate the coefficient, so 1 over 1, isn't it? And we are getting what? Horizontal asymptote to be 1, which is here, isn't it? The one which is actually here, there. That's how we are finding for the horizontal asymptote. Now, we find for our x and y intercept. How do we find those? So for y-intercept, we equate x equals to 0, isn't it? So when x is equals to 0, we plug in 0 in this function. We find that our y-intercept is here to be 0 minus 3, then here to be 0 minus 1. Now, -1 times -3, it's simply +3, right? Now there's 1 here, 1 divided by 3, it's 3, which is here, our y-intercept, which will take place at 0, 3, isn't it? Now, our x-intercept of this function is when y is equals to 0, right? So now, when y is equals to 0 here, you discover that when y is equals to 0 here, you discover that this guy, it will go away, isn't it? Because it will be 0 times this function, and then this function will be equals to 0 still. Then you realize that you have something like this. You have something like this down here. You have something like this. So when you are finding for your y-intercept, you have x minus 3, open, close, x minus 1. So now when you solve for x, you discover that your x-intercept will take place at x is equals to 3 or x is equals to 1. Now at these 2 points, y will always be equals to 0. So we have 3, 0, 1, 0. So now when we are now plotting, we know that we have 0, 3 here in our y-intercept. So here we are starting from 0. Then 0, 3 it's there, right? Then we have 0, 3 which is there, and we also have 3, 0, right? 3, 0 takes place here, isn't it? And then we also have 1, 0, which is here. When you look at these two values, isn't it? So this is the x-intercept. So we have 1, 0, 3, 0. So we even have an idea of how our graph is going to look like, isn't it? So you know that our graph, when it's coming from this side, it will pass through this point. It will pass through, it is coming from negative, this positive infinite, right? Going this way, isn't it? It will pass through this point here, the intercept. Then when it passes through this intercept, it will cross this term, the horizontal line, which is here at 1. It will cross it and pass through this point here, which is at 3, and then it will go up again. So for this part, I believe you just have to follow the point. It's like they are guiding you on how the sketch is going to be. You just graph the point, and then one thing you should keep in mind is that this graph can never cross this line here, your vertical asymptote. because any function which crosses the vertical asymptote, it will be undefined. But you can cross the horizontal asymptote, the function will still be defined. So now how do we graph the other part here? When you have noticed that there's this new line here, the vertical asymptote, right? There's this new line. We have graphed for the right-hand side. How do we graph for the left-hand side? We pick values. Let's pick -2, isn't it? So now when we pick -2, you discover that if you put -2 here, isn't it? You put -2, it will be -2 plus 1. It's negative. -2 plus 1, it's negative, isn't it? Now the negative squared is simply positive, so we have positive there, right? Then -2 minus that, it is still negative. And then -2 minus that, it is still negative. So negative times negative is positive, right? Over positive here. So you have realized that your graph will be bending towards what? Towards what? Towards positive side, isn't it? Towards positive side, isn't it? Toward positive side. So here we pick the value, right? Okay. To proceed. So we realize that when we pick -2, the graph is coming from this side. We pick -2. When we pick -2, our graph there was given as a positive. So it's simply heading towards positive side. Is it clear on this graph, please?
No, sir.
Yes.
Are we tired, or maybe we call it a day?
No, not yet.
So we
No, not yet.
We are
It's just
tired.
that
We are no longer understanding.
We are tired.
these
We are no
graphs are
longer
confusing,
understanding.
sir.
Align to us.
We are dead because we can't understand anything.
Not yet.
Yeah.
And then the last lectures,
Send that over. Just send that over.
Because we need time
Just send that
to
over.
process everything. It's too much.
All right, I
Just
don't
send that
we'll
over.
call it a day. We'll call it a day.
Yes, please. Yes. Please.
Oh,
Let's
no,
go
sir.
with it.
We need to send that over.
Sir, you should send the link so that we watch it from the start, because some of us, one, we joined late, two, we are lost.
I'll send the link, please. But the YouTube channel is shared as well.
Sir, I've got a question.
Yeah, you can even send the link for the YouTube channel.
All right.
Sir,
Yes, carry on, please.
when sketching these graphs, apart from the asymptotes, the Y-intercepts, what else are you supposed to find?
Apart from the asymptote, you have to find what is the X and Y intercept.
After that,
You can even pick other values, and you can pick other values in that region where the function is or the graph is defined. You can pick any values so that you have more points if you want. Because those that I was doing were just half sketch.
no, why were you not doing full sketch? As you're teaching us, Mahab.
No, like like as long as like the way I was showing you guys, that it's now easy for you now to graph. When you just master that key concept to say when you plug in any value, it's going to the positive side. You know how the graph is going to be. Because you just have to master where the graph is coming from. Then the direction where it's going to be bent, you determine on when you plug in that value. the function, there's no need for me to pick every value. Now, for you guys, if you're not getting the shortcut, you can pick more values to help you understand it better. Is it clear though?
So,
All right, see you people.
So, sir,
Yes.
sir. So for the links, for this same video, as well as the one for the YouTube channel, you are sending it to the TG reps?
Yes, I'll send them to the TG reps.
Okay, because all right.
All right, thank you.
No
We
further
really
comment. Thank you.
appreciate. Thank you.